My name is Georg Schaumann. I'm 33 years old and I am starting with my colleague Stephan the company SenseUp Biotechnology, which will bring enhanced biotechnological production strains into market.
We know each other already from our studies. We are both biologists, and we did our PhD thesis at the Forschungszentrum in Jülich, translated research center in Jülich, and there we developed a platform technology for the high throughput screening of microbial producers to produce products like amino acids, which are also other products which are actually produced on the basis of raw oil, and we are trying to drop in these products into chemical processes and therefore to introduce biological production processes based on renewable resources.
In biotechnology, there is a problem that you have to find the best performing cells out of millions, and it is not easy to detect the productivity because you can't see the products or easily detect them in any other way. And therefore we developed intracellular sensors which transform the productivity of each single cell in an optical signal. And with that we can screen cellular libraries in very high throughput and easily identify those cells which perform best. Thank you very much for this great introduction, and thank you for this great audience. You already heard it, we are talking about biotechnology now. And you also heard that the core component of the biotechnology value chain are bacteria, are microbial production strains, which transform renewable resources like glucose or starch into more valuable compounds like amino acids for food and feed applications, maybe proteins, vitamins for pharma applications, or dicarbonic acids for biopolymers. Essentially, these little bacteria here drive multi-billion-dollar markets, and they do it by being fermented in those like fermentation plants like this one here from Ajinomoto in Japan. So this great value chain looks very nice, but there is a hidden problem. And this is that the availability of those production strains is limited. Thus, novel biotechnological processes can't be established as fast as they should be, and current processes can't be optimized as fast as they should be. When you take a glass with bacterial cells, just a normal glass as you use it to drink juice or tea, you have several billion cells, and each cell differs from another. They all perform differently, and to have an efficient process in large scale, you need only the best ones. Unfortunately, the products are not colored or in any other way easily detectable, so you have to analyze each cell individually, and with much time, effort and money, you can maybe analyze 100,000 cells per year, meaning you will never look at all cells you have and you will not find the best ones. Exactly this problem is addressed by our new SenseUp technology. We visualize the product formation in every single cell, and by that give an optical signal which can be analyzed in high throughput. You here see the cells of Corynebacterium glutenicum. That's kind of a workhorse for the industrial biotechnology. Here we have cells which show low productivity. So these cells are much more valuable and they emit higher fluorescence. And here you see the cells we want to have. They show highest productivity and they emit highest fluorescence. Exactly this optical signal is needed to screen cells in high throughput, and this is illustrated here in this movie. I hope it starts now. Yeah. So here you see a cloud of dots, and each dot corresponds to one cell. We here analyze now 30,000 cells per second. Please compare that to 100,000 cells per year. And here at the y-axis, the fluorescence intensity is plotted. We have now here many cells which don't show enhanced fluorescence, meaning they do not overproduce a desired compound. We developed this technology to a platform technology with broad applicability. In the first instance, we focused on amino acids for feed and food applications, but now we are also able to screen technical enzymes, which are very important in the chemical industry to transform byproducts to fine chemicals, and we transferred it to proteins, which become more and more important, for example, in pharma applications. We will launch the startup company Sensab in July 21, I think. We have the date at the notary. And we are a great team from innovators, experienced entrepreneurs and skilled scientists, and I promise you will hear from us again. Thank you very much.